Let's start our session with the minimization of SSOP, SPOS expressions with don't cares. So now what is the use of your don't cares and what does mean by don't cares? And in my minimization technique, how you are going to represent these don't cares and minimize your functions. So those all the things we are going to discuss today's session. So now let me define what does mean by don't care conditions. So don't care conditions are the input conditions where the output which will not affect your system. So such type of your conditions are termed as a don't care conditions, and for few functional values of your given function may not be represent for few combinations of your input. Such type of combinations of your input, such type of combinations is called as don't care combination. For such don't care combination, your functional values are not specified, and these are denoted in your truth table or in your K map with a letter X or with a letter D or with a phi symbol. So these are the symbols we are going to use. It can be represented with X's, D's or phi. So now for example, so where these don't cares occur is in your BCD code. So for example, in your BCD code, we are going to represent your decimal numbers from 0 to 9. So 0 to 9 is represented with 4 binary bits. So 0 is represented with 0000 and 9 is represented with 1001. So now 10 is represented with 8 bits, not with the 4 bits. So 10 in your BCD is represented with 8 bits, not with your 4 bits. So hence here, so the when you compare with the binary, so these 10 which is 1010 in binary and 15 which is 111 in your binary number system. So if I count from your 1010 to 111 total, I'll have 6 invalid states in your BCD. For such input combinations of these 6 combinations, so your functional values in your BCD is not specified. So such type of your output functional values are treated as a don't case, and they were marked with a D letter or with a X letter or with a phi letter. Now I have given a truth table with 3 variable and a function with the 3 variables. So these functional values of minterms and maxterms are represented here, random values, and including with that minterms and maxterms. Additionally, we also have the don't case, and for this function of f of x y z, they don't wanted to use the combination of 2, so 0 1 0, as well as a combination of 1 1 0. So for such two combinations, if your functional value is not specified, it is marked with your x value. So now, so this is the way of representing your don't cares in your truth table or in your K-map method. And while you are minimizing in your K-map method, so you have to treat these values of don't cares might be assumed values as logical 1 or logical 0. And so you can assume the don't care values are logical ones and logical 0 for minimizing SSOP expressions or SPOS expression. So if you are assuming those values, you can form your with your don't including with your don't case with the minterms or maxterm into a large group. So that large group can lead to your simplified expression, and that simplified expression will be designed with a simpler circuits, so with a simple logic. So now don't case can be used to form a large groups which can form into a quads, or it can be formed into octets, or it can be formed into a pairs by treating their values as either a 1 or it is a 0. So in standard SOP, the don't care value is assumed with a logical 1. In standard POS, that don't care value is assumed as a logical 0. But when you are representing that don't care on your K map, it must be represented with X value only. So we should not mark this as a 1. So we have to mark on your map your functional value of don't care with X or D letter. So now large group of your K map can simplify your expressions with less number of literals, and since each group reduces, each group of your large group can reduce more number of variables. So now let I explain this how to minimize your function of SSOP in a 3 variable with don't case. Now this is the way of representing your function with don't case. So as here I used m of 1 comma 3 comma 7. So function is in standard SOP. So they have given your min terms which is m of 1 comma 3 comma 7 plus don't case 0 5. So out of the 8 midterms. So 3 are your actual midterms and 2 are your don't case. So let me map your function first. So 1, 3, 7 are mapped with the logical one as 0 and 5 are don't case. So we have represented on the corresponding cells of 0 and 5 with a X symbol. Okay, so with the X symbol or cross symbol. So which did with the don't care symbol. Now let me start our grouping. So if I am going to use your normal procedure only covered with the midterms. So there is a only possibility of pairing. So we can pair only. So we have two groups. So where these two groups have each will have two midterms. So which is only the pairing. So a pair eliminates only one variable. So which leads to more number of variables. So now, so instead of that, so now let we so assume your we will assume your don't case as logical ones. So when I assume these don't case are logical ones, so since 5 is also there, so if I assume this value, so imaginary value of this is, so let us take this as a 1. So if I assume this as a 1, so then I have a 4 square adjacency, then I can form a quad. So now this quad will have the minimal expression. So here the row wise the variable A is for this group, only one group, with the one group the 3 midterms are covered. So your final expression of this function is A variable is different, where B variable is also different, only the C is same for all the 3 midterms along with the don't case. So now hence here, so my final expression it is C. Earlier if I use your so only with the midterms, so I have your two pairs, so which will give two groups. So first group will give you the product term as A bar C and second group will give you the product term as BC. Now if I treat the don't care as logical one, so this expression now it comes to the minimal expression only with the variable of C value by assuming the value of don't care with a 5 with a logical one. And now so here no need to cover your all the don't case. Now so wherever we require to cover your midterm, so there we can assume that value of x and we can cover that into your large groups. So now here I no need to cover this don't care, so just I left this don't care as it is. We should not cover your all the don't care. So these don't cares are used to cover your midterms only or to form into your large square only. So like this, so we can leave the don't case which is not at all in useful to cover into your midterms into your large groups. So like this we are going to minimize your functions. Now let us take another example. So with the 4 variable, so 1, 5, 6, 11, 12, 13, 14 are my midterms with only one don't care of 4. So if I don't use the don't care here, so then if I don't assume this don't care here, there was a possibility only to take your pairs only. But if I assume this value of don't care is 1, so then I can form total of almost here we can form two number of quads along with one pair and one isolated midterm. So if I doesn't assume this value as 1 or if I doesn't take this into your grouping, so then I can only have a chance of pairing. So almost we have total 5 number of pairing with one isolated midterm. So hence if you treat this as a don't care, so this corner cells, so these two, so where it is fourth midterm, so which is a don't care, as well as here we have 12th midterm. So next on this side 14th midterm as well as your 6th midterm can form a quad because these are in left corner and right corner, so forms a quad if I consider this don't care as a logical one. Next, in order to cover your uncovered minterms of 5 and your 13, so now I can use the already covered minterm which is 12 along with your don't care. Then I can also have your 1 quad. So then here let I cover your minterm 1 with your minterm 5 and only one minterm which is left alone, which is a isolated minterm. So these two quad minimal expressions are BC bar. So and your BD bar is the second quad minimal expression, and your pair minimal expression is row wise A value is 0, so hence A bar, and column wise your C value is 0 and D value is 1. So these are the common variables of pair. C bar, D is the product term. So next, only one left isolated minterm which doesn't have any adjacency. Hence, so this isolated minterm as it is written as AB bar CD. So A value is 1, B value is 0. So AB bar, CD are my column variables on your isolated minterm. So this is treated as a isolated minterm. Now let me do another problem on your SPOS function. So when you are minimizing your SPOS function with the don't care values are assumed as zeros. Now in this function I have total 4 max terms with 4 don't cares. Now upon mapping, let me check for your actual grouping. So if I doesn't consider these max term as don't cares as a max term, then there was only the possibility we can only have pairing. So these two pairs with the two pairs, so we can cover here all the max terms. So instead of that, so this pair can eliminate only one variable from your 4 product terms. So hence, so don't prefer your least square adjacency. If you have a possibility with the don't case with a large square, you have to prefer or we have to assume the don't case as a 0. So now if I assume don't case as 0, I can form a two quad groups here. So these two quad groups can eliminate, each quad can eliminate 2 variables from your each sum term. So this green quad will have the variable which is row wise A value is 1 as a sum term. The first group sum term is A bar or of C value is 0. So A bar or of C is the minimal sum term of this quad. So next, this quad after upon considering your don't cares as 0, so then we have here row wise B bar or of, column wise C is 1, so B bar or of C bar. So like this, so we are going to assume your values of max term, don't case with a value of logical 0 and covering into your large big square will minimize your simplified expressions. So your functions are minimized with simplified expressions. Next, minimize your following function with the don't case. Here I have mentioned. So now you have to practice by considering here the don't care values upon this considering. So we almost have 3 quads with 1 pair. So those 3 quad variables are A bar D, A bar C and AB, and this pair which will have AC bar D bar, and one don't care which is not at all used. So just leave that. Next, in example 5, I have given a function which is in standard SOP. So with the grouping, so here one don't care is not used out of the 3 and the remaining 2 are used in order to form into a big square. So upon considering these values, we could have total 3 quads with 1 pair. So corner cells are adjacent if I consider this don't care as 1. So next, so these upper row and your bottom row are also adjacent, so we can also form another quad. So next, here also I have mentioned another example with a sum of product form, so which is in the form of max terms. So now upon considering these all don't cares as 0, we can form an octet in order to cover this 2 max terms. So we obtain a sum term which is A bar, and to cover these 2 max terms which are 6 and 7, I consider these 2 as a logical zeros upon this. So we have B is 1, so B bar as a sum term, and C value is 1, so B bar or of C bar is your minimal expression of your last one. So this is a today's session, how to minimize your function using don't case. Thank you. In next session, we are going to realize your NaN implementation.